So on this next section, we're going to go ahead and find the given or the indicated trig values. They will always give you one of the trig values. So in this case, they gave us cosine. So it's going to be important to know, to remember your SOHCAHTOA for this. So remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So I'm going to go ahead and draw a right triangle. So always just draw a right triangle. It doesn't matter how you draw it. You can just make it look exactly the same every time if you want. And then since we have cosine, remember cosine is adjacent over hypotenuse. So cosine is 3/5. That's what it tells us. So the 3 is going to be our adjacent side. The 5 is going to be our hypotenuse because it's adjacent over hypotenuse. So I'm going to go ahead from this angle. I'm going to go to the adjacent. Oops, I put the opposite side. So adjacent side. So that's the one touching the angle. And then the hypotenuse is always across from the right angle, so over here. So I'm going to put that as 5. Now to find the rest of them, we're going to go ahead and use Pythagorean theorem to find this side over here. So I'm going to mark that as x, and we're going to do Pythagorean theorem. Remember, when we did Pythagorean theorem, I always start with the hypotenuse, so that's 5 squared. And then I set it equal to the other 2 squared and added together. So 5 squared, I'll type that in. I get 25. And then we have x squared. And then 3 squared is 9 if I type that in. Let's move this over here. So at this point, I'm going to subtract 9 from both sides. So I have 16 equals x squared. And then just go ahead and take the square root, and we get 4 is equal to x. So I'm going to go ahead and put this as 4 right here. And now we can go ahead and find our sine and tangent of this angle. So sine of theta would be opposite. So this is our opposite side. In fact, let me do a different color. So this is our opposite side from the angle. We know this is our hypotenuse, and this is our adjacent side. So sine is going to be 4 over 5, because it's the opposite over hypotenuse. And then tangent is going to be our opposite, so 4, over our adjacent, so 3. And there you go. Let's go ahead and do another one of those. Okay, once again, I would always make a little triangle. If you make them all look exactly the same, that's okay. Just make sure it's a right triangle. And we're going to go ahead and find or use our SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So we've got sine. They gave us sine, and sine is 5 over 8. So the 5 is our opposite side, and the 8 will be our hypotenuse. So hypotenuse is right here. Opposite is over here, adjacent is touching the angle right here. So according to this, our opposite should be 5, so this side is 5, and the hypotenuse should be 8, so that's 8. And now let's use Pythagorean theorem to find it. So you always start with the hypotenuse, so 8 squared is equal to 5 squared, and then I'll call this other one x squared. So this one right here. 8 squared is 64, 5 squared is 25, so you'll just type that into a calculator for both of those. Then we'll go ahead and subtract 25 from both sides. So 64 minus 25 is 39. And then you take the square root of both sides. So x is equal to, I'm going to write it right here, x equals the square root of 39. So I'm going to write that right here, square root of 39. So these are the numbers we're really paying attention to right here. So let's go ahead and find our other one. So we already had sine, sine's good, so we need to find cosine. So cosine of theta is our adjacent, so square root of 39, over the hypotenuse, which is 8. So I was just using this stuff. Tangent of theta is going to equal our opposite side, so 5, over the adjacent side, which is square root of 39. Now this tangent one, having a square root on the bottom is actually not technically allowed, but we're going to learn later in the year how to simplify that. So for now, just go ahead and keep it like that. Let's go ahead and do one more. So once again, make a right triangle. Mark your angle. Probably haven't said that enough. So we want to mark the angle that we're using. We have cosine, so if we're using our sine SOHCAHTOA, so SOHCAHTOA, okay, they gave us cosine, so we've got adjacent, we've got the adjacent over the hypotenuse. So our hypotenuse is this one, because it's across from the right angle. The opposite side is going to be over here, because it's across from the angle that we marked. And our adjacent will be this side touching that angle. So the 5 will be the adjacent side. The hypotenuse is the 9. And we need to find our opposite side by doing Pythagorean theorem. So I'm just going to go ahead and for now call that x. And I always start with the hypotenuse, which is 9. So we have 9 squared equals x squared plus 5 squared. 9 squared is 81. 5 squared is 25. Then I'm going to go ahead and subtract both sides by 25. So 81 minus 25 is 56. And then go ahead and take the square root, both sides. Now, if you type this into the calculator, you'll get, well, it depends on what calculator. So sometimes you'll get a decimal. If you get a decimal, just keep it as square root of 56. If you're using one of my calculators, it'll tell you the answer is 2 square root of 14. And so from there, either one, I don't care which one you use, I'm going to go ahead and just keep it as square root of 56. What I'm going to go ahead and do is I am going to put this in as all of mine. So I've got sine of theta is equal to my opposite side, so square root of 56, over my hypotenuse, which is 9. And then they want us to also find tangent. So tangent of theta, remember, is opposite. So the opposite is square root of 56 over the adjacent, which is 5.